Iron is a key driver in many natural processes. In wetland ecosystems, iron greatly affects how nutrients cycle through plants and soil, like in the nitrogen cycle shown here, which influences plant growth. The concentrations of iron and other chemicals in soils depend on human activities and infrastructure like roads, dams, and urbanization. Hello, I'm Mukta Kantak, and I'm an environmental science major at UT Austin. This summer, through the UD Envision/Summer Institute Program, I had the opportunity to work with Dr. Shreeram Inamdar, as well as postdoctoral researchers Dr. Eric Moore and Dr. Mukta Raman, to investigate the relationships between road salt application and iron concentrations in wetland soils. We first collected soil and water from 13 different wetland sites, some more affected than others. The soils were desiccated and dried, then massed for bulk density. Then, we ground them up using a ball mill grinder. Now that it's a fine powder, it's easier to work with, and we can start with the extraction methods. We used two different extraction methods to separate the different forms of iron from the soils. One method used oxalic acid, and the other used sodium dithionite, a powerful reducing agent. Both of these methods yielded a liquid solution with suspended soil particles. After the extraction solutions were added, samples were shaken and then centrifuged to separate out the solid soil from the liquid, which now contained all the iron. The liquid samples were then analyzed using an inductively coupled plasma atomic emission spectrometer, or an ICP-AES. This machine uses plasma to produce ions in each of the samples, then detects and counts the ions to distinguish the concentration of each element present. Using this data, we can then determine how much iron is in each sampled wetland site, and then compare that data against the sodium and chloride concentrations from the road salt. One could further expand to research impacts on other elements or nutrient cycles, like nitrogen or phosphorus. It is incredibly important to study wetland ecosystems so we can develop strategies to mitigate damage, restore critical ecosystems, and promote sustainable practices. Almost 25% of Delaware is covered in wetlands, and they provide many services like improving water quality, giving habitats and ecological niches for organisms, and storing floodwaters. However, Delaware has lost almost half of its wetlands in the last 250 years due to land development and agriculture. Research about human impact on ecosystems can inform large-scale conservation efforts, public awareness, and policies that can foster the preservation of natural habitats. This research experience was incredibly meaningful to me, and I really enjoyed working with Dr. Inamdar's group this summer. It truly encouraged me to think like a scientist and envision the real-world impact of environmental research.